afternoon, and welcome to today's webinar, Building AI Trustworthiness with ISO 42001 Implementation and Benefits. My name is Chavinder Kaur. I'm from BSI Marketing team. I'm here to facilitate this session. Before we start, I would like to give you some ground rules. You all have joined the webinar as on listen only mode, but please feel free to type your question in the question box on the webinar control panel. Our speaker will do their best to answer as many questions as possible at the end of the webinar. If due to time limit your questions are not answered, then we will provide them after the webinar. This session is being recorded and you will receive the recording shortly after the webinar. I am delighted to be joined by our today's speaker, Mr. Dheeraj Saxena. Dheeraj Saxena is our subject matter expert and specialist tutor for various best practices in the IT-enabled sector. He is a lead auditor and master trainer for multiple disciplines such as IT service management, information security, privacy, business continuity management, and corporate integrity management. His total experience exceeds 33 plus years, out of which the initial 18 plus years were infused with IT service management and information security for leading organizations. During the last 15 years, Dheeraj has been auditing and educating on digital trust, governance, and compliance using an integrated system approach. Now, to start with the webinar, I would like to thank and I would like to hand over to Dheeraj sir. And over to you, sir.
All right, thank you. Welcome everyone. A very good afternoon to everyone. And in the next 1 hour, we are going to talk about primarily AI trustworthiness and what are the nuances, what can be done to address those nuances and risks. This webinar is basically in a concise summary form and it's meant for general guidance only. We are not going to propagate any technical product or service for any other organization. With that, let's get started. So three main agenda items. First and foremost, what are the risks? What are the factors which are critical to responsible, trustworthy AI? That's going to be the first section. Then we're going to see how these risks and opportunities can be addressed effectively, repeatably, demonstrably by the ISO 42001 standard, which is a globally acknowledged set of best practices. And then we're going to quickly also culminate the session with discussion about how to have an integrated approach to managing AI trustworthiness, managing the entire AI program with your existing ISMS and privacy information system in place. And we'll definitely have some time for Q&A as well. So let's get started. So what is trustworthiness? It's a composite metric. The one-line definition is there in front of you: ability to meet stakeholder expectations in a verifiable way. That means which is auditable, traceable, there's reasoning available, and stakeholder expectations in terms of truthfulness, accuracy, security, privacy are met. Other characteristics, and this is the ISO definition, comprise accuracy of the prediction of the AI model, the fairness or the minimization of bias in the predictions, the transparency with which the decisions or recommendations are made by the AI model, and of course the underlying security, privacy, and accountability as well. When we talk about accountability, primarily we're looking at legal and regulatory compliance. So one by one, we are going to unravel all these aspects in the next maybe 15, 20 minutes. Let's take an example here in our day-to-day lives. This could be an example of you and I. So imagine that we are applying for a loan from a bank, and this loan system is operated by AI. So that means our loan applications are going to be screened and either approved or disapproved by the AI application. So that's the premise here. Now look at this table. I've depicted the possible outcomes in a matrix. And in the column, you have actual people who are credit worthy. That means they are deserving of the loan, or either they are not credit worthy for whatever criteria which have been defined. On the rows, we have the prediction by the AI model. Either they are predicted credit worthy or not credit worthy. Now, these two circles which I put here are the ideal conditions. So either people who are actually credit worthy will be approved, their loan applications will be approved, or if they are not actually credit worthy, then ideally their loan application should be disapproved. But that's the ideal condition. We know for a fact that at best AI is there for prediction, and whenever there is a prediction element, there's an element of error also involved. So let's look at some of the other options. Now, look at the false negatives. These are people who are actually credit worthy, but then for whatever reason, the AI system is not able to discern their credit worthiness and has finally taken some decision based on some classifiers that they are not credit worthy. So we call it a false negative. Now, obviously, if I and you are in that position, it will lead to a lot of dissatisfaction. So there's a risk of dissat for all those false negative options or customers whose loan has not been approved despite being credit worthy. Now, how to minimize that? Obviously, it's in the interest of this bank to minimize such occurrences. So they come up with some kind of a metric. Now, usually this is called error rate analysis, and in the error rate analysis we have a metric called recall, which actually is used to find out whether the AI model can actually find all instances of positive class. That means whatever was true or not. So in this situation, given the numbers that I put in, the recall value comes out to be around 71%, which is not the best in terms of industry best practices. That means after getting this measurement, the bank has to then tweak its AI model and reduce the dissat. Let's look at another example here. Now, these are the false positive. That means AI model has predicted these applicants as creditworthy, approved the loan, and yet for whatever reason, they are not fitting the creditworthiness criteria. Now that's an operational risk. Why? Because you don't want uh, people with a risk of default being approved in terms of loan applications. So that's an operational risk, again, has to be reduced or mitigated. So how do we do that? We measure first. And then there's another metric uh, for the error rate analysis, which is called precision, which is basically giving you an indication of what percentage of correctly labeled positive outcomes are there out of those which are actually labeled as positive. How many of them are correct? So again, here, as per the numbers, it turns out to be around 83%. So again, there's an opportunity to increase that metric. Now, the point we are making is that there are limitations of AI models because of the inherent bias or uh, the fact that they are just predicting, right? So there needs to be some kind of error rate measurement in order to control these error rates, minimize them, and hence make the model more and more trustworthy. That's an imperative here. Let's look at, so we've talked about accuracy here in terms of recall, precision, and so on and so forth. Now let's look at some other aspects of trustworthiness. And here we're talking about bias. Now, the word bias in the context of AI means uh, some kind of a systematic difference in the treatment of certain groups of people or objects, and hence leading to discrimination. So, for example, uh, if you take the instance of a recruitment system, which is based on AI, is it discriminating against the female gender, or is it discriminating against old aged people for whatever reason? That's an inherent bias here. So the challenge is ensuring demographic parity and inclusivity. That means we don't want to uh, change the output of the AI model just because we have different kinds of data set. Whether the data set is of European people or people from Asia Pacific, we want it to have the same precision, recall, and accuracy, the metrics which we talked about in the last slide. Just before we go to what are the ways to minimize bias, let me give you what are the different types of bias, and there can be many. I'm just taking examples of three here. So one is the representational bias, which is primarily data being skewed. That means the distribution is not normal, or maybe it doesn't have enough representation from various demographies. So example could be a facial recognition system. You've trained the AI model using the input from population in Europe, and you've not trained it on facial recognition for populations in Asia Pacific. Now that's a representational bias because the data itself is limited, uh, and this it's a sampling issue basically. Sometimes in the data you may not have real data, and you're using proxy data. That means indirect indicators. So for example, uh, instead of actually having data about credit worthiness of people, you're having data on their location, and you're just using the AI model to infer that if person from this location is applying or this background is applying, then probably he or she is credit worthy. So that's proxy data. That means lack of actual genuine data. That could be another reason for representational bias. Let's look at another type, which is algorithmic bias. Now here, the algorithm developed by the AI engineer itself may be flawed, or it may have unfair weightage to certain parameters. And take the example of a AI algorithm, which is actually learning, and it is looking at current trends. And suppose it's used for recruitment, and the AI algorithm has deduced rather, that persons with the name John, they're being fired recently by the organization, or they were rejected in terms of the resume. And people with the name John, the freshers who are applying, it might deduce that their application should be rejected because it has learned it from the current trends. So that's an example of algorithmic bias. Or we may have a cultural bias. So many a times these large language models are not able to understand the context of the question. Suppose you're using some idioms or metaphors in your query, they may not be able to understand. So various types of bias can lead to inaccurate predictions. And what are the opportunities here to minimize this? So let's look at some checkpoints. How are we measuring the fairness metrics? Because ultimately we want to ensure that whatever data set we are deploying of whatever demography, the accuracy or the prediction is similar. It does not change. So what is the relative contribution of recall and precision? Remember the two error rates which we saw in the last slide. And then we have some scores such as the F1 measure of the F1 score, which actually is a harmonic mean of precision and recall. And the higher it is, it can vary from 0 to 1. So the closer it is to 1, that means the lesser the bias. Indicator, it's an indicator basically. Coming back to the data quality itself, have we considered richness of the data in terms of the number of groups that have been sampled or trained? Is it even or not? Even in the sense that is every group getting a fair share? It's not that, okay, yes, different groups were considered, but then only 5% of one group and 80% of another. So it's uneven. So that has to be looked at by actually running the data through some tools. And what about human oversight and consultation during the training of the model? How inclusive is the group of analysts which are actually uh, evaluating the model, assessing the model, looking at causation? That means for whatever output given, what is the cause? Is it just correlation with the current trends, or there's a reasonable cause also? So that has to be looked at. In fact, not just during the training and testing, but maybe after the model has gone live in the live environment. And then what about data management process? We will touch upon this quickly, the data management also, and is it effective? So I talked about data management. So let's just quickly delve further into that. And these are the broad steps which you may have in a data management process while even before you train your model. So you acquire the data, uh, and we have something called as data provenance. That means you're verifying whether the data is authentic or not. You're looking at the distribution, looking at the standard deviation. Um, is it representational or not? Okay. Is it current or not? All these aspects, which we call as metadata about data, are looked at in the acquisition stage itself. And you may want to get this kind of self-certification from your vendor if you're sourcing it externally. Or if you're feeding production data from your live environment, then again, one has to check this. So data provenance is important. Once you've done that, then you explore the data in terms of what kind of distribution is there. Are there some outliers or extreme values which are not plausible at all? Are there some patterns such as skewness or standard deviation is varying a lot? And then you see what kind of training has or labels are already there, so that you can, they can help in training the data for the model. Once you're done with that, then the wrangling and the cleaning process, in which you are organizing the data, maybe it has come from the internet, into very structured data set. You're removing the duplication, you're correcting the errors, or maybe identifying missing data, putting in some proxy data. All that is part of wrangling and cleaning. And then you want to ensure that the sensitive personal information is hidden. So data perturbation, which is swapping and obscuring of sensitive data, identifying bias, all this has to be done. And again, addition of metadata for enhancing the model interpretation. That means if there are decisions being made, on what basis are they being made? So this will help in explainability, which we'll talk about very shortly. So how often do we retrain the model or address data drift? Data drift may change because buying patterns have changed, for example. And now that the data which you're feeding in is of a different customer behavior altogether. And how are we testing the model through continuous monitoring periodically? Is it consistent in an output? Are the error rates fluctuating? Remember the error rates that we talked about? All these are checkpoints that we have to have. Let's talk about another aspect now, which is addressing explainability. So what is explainability? And if you see in the center, we've written it, ability to explain both the technical processes and the reasons behind the decisions or predictions. So if a loan application is rejected, what was the reason? Uh, does the person does not have sufficient balance in the account, or is the credit score below par, or whatever? Those reasons have to be clearly mentioned. That property is called explainability, and tracing it back to whatever computations have been made. And so traceability and auditability are must if you have to make the AI model explainable. So what are the checkpoints here? What can be done by the organization? What controls can be put here? Let's see. So first and foremost, how are we measuring explainability? So for example, if for say out of 100 applications, there was no clue for at least 35 different applications why they were rejected, then explainability is an issue. So the percentage of transactions which don't have a backup reason or interpretability, that gives us a measure of explainability. So that means we have to improve that metric. Can we trace back which data or rules were used by the AI system to make a certain decision or recommendation? What were the criteria? Have the model parameters changed? What has changed? So again, we have to make it auditable. Are we periodically surveying our users? if they comprehend the decisions of the AI model also. So take customer feedback. Don't just do continuous monitoring evaluation of the model, but take feedback from the customers. What were their perspective on interacting with this interface, right? And then what are the various ways in which humans can intervene and control these decisions? So what control does the human being have here on these decisions? Is manual override possible or not? These are some of the opportunities or checkpoints for addressing explainability. And remember, if explainability is below par, then again it will lead to dissatisfaction, which we don't want. Now let's come to another a very, very important aspect, which is transparency in AI. So here, the keyword is proactive. Proactive, open communication about the features and limitations of the AI system. So suppose, first and foremost, when the user starts interacting with the system, does he or she even know that the user is interacting with an AI system? So who will tell them? Who will proactively inform them? They have to know that they are interacting with an AI system. Then they have to know how to operate it, what are the limitations, what's in scope, what's out of scope. And that all has to be explained in a very comprehensive, easily accessible, understandable manner. Okay, it should be obvious. It should be very simple. So that's what we want. And if it's not there, again, trustworthiness will take a hit, which we don't want. So what are the opportunities and checkpoints here? Do we proactively inform users about the features, limitations, level of accuracy, need for consent? Are we even taking their consent in a very simple manner by making it very clear to them why we need their personal information? Are we communicating to the users that they are interacting with an AI system instead of human? Do we provide adequate training to the users, and so on and so forth? So these are some of the considerations which you need to address for transparency. And what level of logging and traceability is available to the people who are interacting and evaluating these models? I mean, so are they aware what are the reasons behind these decisions? So are they able to look at the logs, analyze them, and so on and so forth? These are some of the important aspects. With that, having understood to some extent what is accuracy, fairness, or absence of bias, explainability, the importance of data, I would like to get your sense in terms of this poll. So I'm going to ask my colleague Chavinder to open up a poll in which we've given you some options, and we're asking you which aspect of AI trustworthiness do you find the most relevant for your organization, in your organization's context. And we've listed 4 of them, or there's an option all of them also. So Chavinder, can I request you to open the poll, please?
Yes, sir. I have launched the poll. Uh, Now I request every participant, please check on your screen or the chat box. You will get the quick poll. Please answer it.
So let's give it a minute at least for them to give the options, and then maybe you can broadcast the results as well.
So now we can close the poll, sir, and we can see the result.
Okay, go ahead. You can
Can you
broadcast the
see?
result on the screen. No, I'm not able to see right now. Is it because I'm a panelist or?
No, you can see the poll result on your screen.
Not yet, Chavinder. Maybe you can read it out. Doesn't matter whether I'm able to see or not. You can give us the results.
If I'll say the result is, I can see like most of the like 40% people are saying they are like accuracy of production or recommendation.
Mm-hmm,
10%
mm-hmm.
people are saying like there's a mitigating bias in AI model.
Okay.
5% people are saying enhancing explainability of AI outcome, which is the 5%, and all of the above, which is 15%, they are agree with it.
All right. Okay. So maybe now you can take it off. So then I'll share my screen again. You're able to see the screen now, Chavinder?
Yes, yes, we can see the screen,
All right.
sir.
Thanks. Thanks. So let's resume. We're going to talk about security risks now. And so obviously security risks are entirely different from what we have in non-AI models or the traditional software systems. Here, we've just given you some examples of the most prolific or the severe security risks that we come across. So the first one is data poisoning or manipulation of training data by intentionally injecting misleading information. So as you know, many of the AI models can extract information from the web, and I can come up with malicious data on the websites and actually ensure that uh, the data from these malicious websites is taken by the AI model, either for learning or for looking at the trend, and then it starts giving inaccurate predictions, and it gives start giving malicious data. We've had instances that uh, some chatbots have been released, and they were taking the data from Twitter, etc., and people came to know how they are, inferring their decisions from this data. So they were giving prompts on the Twitter, which was then taken by this AI model in an incorrect way, and within 24 hours it started giving uh, racially uh, racially biased outputs, and very malified information. So that was actually, that has happened a lot with and these models had to be rolled back. Then the risk of confabulation, we know how realistic deepfake looks like. Sometimes becomes very difficult to distinguish between the deepfake and actual. And many a times, it's not just for images. The output of a large language model, suppose it tells me that, look, Mars is 5.4 million miles away from Earth. Now, I, as an end user, don't have a means to validate, and I may take it as a fact, while it may be erroneous. I'm just giving an example here. So, the confidence with which the output is given, and maybe supported by some data also, makes the user feel that it's the absolute truth. So, the risk of confabulation is a very important risk to address. In fact, uh, maybe a few years from now, just like all of us have antivirus software on our laptops, we'll also need anti-deepfake software on the laptops to help us distinguish whether this is a real video or an artificial one. And then the risk of model inversion, in which um, the hacker is trying to identify from the output data how the model is engineered, and then extracting data from the model. So we've given an example of extracting images used to train a facial recognition system. So and trying to access that confidential data. So model theft is also a very uh, significant risk here. So what are the opportunities and checkpoints? I think let's start from the initial phases in which you're training the AI model. If adequate, effective data provenance procedures are not there, if data management is not there throughout the AI lifecycle, then these risks are more prone to materialize. So the probability increases. Then, apart from that, measures like red teaming, in which we are actually simulating. So ethical hackers within the organizations, a separate team is actually simulating an attack in a very, very non, you can say, harmful way, uh, and looking at vulnerabilities, uh, and then informing the other teams, the security architects, what are the vulnerabilities, and then those vulnerabilities being plugged in. So simulating some kind of ethical hacking or penetration testing by these security aspects or the experts or the red teams, and then treating those risks needs to be done on an ongoing basis. Then continuous monitoring of the model performance in terms of the error rates. Remember the error rates that we discussed in the at the outset. Are those error rates increasing due to changes in data distribution, or are those error rates increasing because of some other factors? What could be the reason? Doing some causal analysis, then trying to tweak the model. So maybe it needs some retraining also. Looking at the shift in data distribution or the patterns of data, or maybe shifts in customer preferences will lead to different uh, unpredictable outcomes also if the data itself changes. So those were the security aspects, some of them. Let's also look at some of the privacy imperatives which are very closely related to information security. So what are the checkpoints here? If the AI model is being used via personal data is also being fed. So is it being anonymized or pseudonymized or encrypted at least? Before that, is the consent being taken from the various people whose data is being used? Uh, and then apart from anonymization, encryption, etc., what kind of impact assessments are we doing proactively uh, on that sensitive personal information, and what kind of controls are we putting in? So are we ensuring that the data is minimized before it is fed to the model? Is purpose limitation also adhered as a principle of data protection or not? Then are we consulting the various stakeholders such as the data protection officer or CISO or other stakeholders, taking their inputs as well before feeding the data or before preparing the data for the AI model? So there needs to be an inclusive approach here. Now, apart from the EU Act, which we are going to talk about very, very shortly in the next slide, uh, most of you would know that there was a blueprint for AI Bill of Rights, and the executive order uh, was signed by the president of US. So, which basically, wants to have safe, secure, and trustworthy AI, and it lays down a lot of focus on data privacy. And apart from data privacy, another principle in the AI Bill of Rights of the US is appropriate notice and explanation to be given. Now that corresponds with transparency and explainability also. So remember, we talked about in transparency, proactive information being shared. So that's for the privacy notice, and explanation also. That means what is the purpose for which it's being collected, or maybe if there's a decision being made, what's the reason behind that decision, and giving the option to the data subject to opt out as well. So what are the human alternatives? Can the data subject opt out and uh, get that data erased or not? All those uh, rights of data subjects, which we know from various legislations like GDPR, etc., must be upheld. And then in order to ensure safety and effectiveness of the privacy management system, what kind of risk management are we doing? So the US has come up with the AI RMF, or the risk management framework, which they want all federal departments to follow. And it's on AI basically. So proactive risk identification, analysis, evaluation, and treatment is what we're saying here. And of course, we talked about reduction of bias. So that is also accentuated in the AI Bill of Rights, in which they say algorithmic discriminations protection have to be proactive and continuous. That means throughout the data life cycle. So just giving you an idea of what the various laws are saying. And let's now have a quick look into the European Union AI Act, which was promulgated last year, which came into effect from August last year. And the initial provisions have now started getting applicable from 2nd of Feb. And it's a staggered implementation which will go up to August 2026. Just like the GDPR, EU AI Act, European Union AI Act also has an extraterritorial scope. That means whether the system is kept in another country or being imported from another country, but if it's being used for the citizens of European Union, then they are also liable to the provisions of this act. Now, they have got a risk-based approach here, and they've categorized various uses of AI into various categories of risks. So irrespective of the technology which you deploy, what is AI being used for? I think that is the criteria of the EU AI Act to impose restrictions. So for example, very high risk systems like social scoring systems. That means you're observing the behavior remotely of people and then ascertaining their scores or giving them some ratings based on their behavior might be discriminatory. So those systems are absolutely prohibited. They're not even allowed to operate those AI systems. Then they have another category called high risk systems, such as, for example, remember the example that we took about on the loan application system, banking, etc., or safety components of regulated products. So for example, toys for children or medical products which are highly regulated, if they are also being part of the AI system, then that AI system is high risk. So what needs to be done for high risk systems? So if you look at the left side box, they have to be registered in the EU database. Then they need to go through third-party assessments, also neutral assessments or audits. They have to have a risk management framework in place. They have to have data governance. We talked about data governance a couple of slides ago. Humans oversight, that means ongoing monitoring, review, and obviously closure of the gaps. And the gaps could be either in the parameters that we spoke, accuracy, transparency, security, privacy, access, etc., and maintaining technical records of all those transactions. So these are some of the, you can say, provisions of the Act for high risk systems. Then uh, then we have limited risk and minimal risk, which I've clubbed together here. So the usual chatbots or the spam filters or general purpose AI, for all these, one has to have transparency obligations, uh, disclosure of the features of the AI system, their limitations, etc. Consent has to be taken, which we talked about in privacy, etc. Then technical documentation has to be there. They have to have a system for evaluating the model throughout the life cycle. We talked about red teaming, that is also called adversarial training. So that has to be done periodically. It has to be simulated and remedial actions have to be taken. And of course, if there are serious incidents happening, then those incidents have to be reported to the national competent authorities. So just like you had supervisory authorities for GDPR, all the EU member nations have to have national competent authorities for purpose of governing AI in the respective member states. So that's just a brief about the EU AI Act, which has already come into force and various provisions will be implemented right up to 2026. So let's have another opinion from you. In your opinion, does AI pose a gamut of new risk categories which were not there in the traditional software development at all? So, Shavinder, let's open the poll.
Yes, sir. The poll is launched. Now I
Okay.
request every participant to please uh, give your responses. We'll wait for more 10 seconds.
All right, let's close the poll now. And let's look at the results.
So, result is we can see 78% people are saying yes, absolutely. 19% people are saying to some extent.
To some extent,
3%
okay.
people, they are not sure.
All right. Okay. All right. So let me put the screen up again. All right. So as some of you mentioned that there's a whole new gamut of risks and hence a whole new gamut of controls or countermeasures is needed. So that's where we have another set of best practices, which can be an overlay on top of the ISMS, Information Security Management System. And that set of best practices is labeled as ISO 42001. Again, comes from ISO, so it is acknowledged by more than 120 countries. They voted for it before it became a standard. Again, it follows a risk-based approach, so ongoing risk assessment for the overall AI systems and at project level. So you need to have risk assessment for the overall organization level also, and for various AI projects which are running in your organization as well. So the risk owners are accountable for managing or controlling the risks for their own projects, just like we had in ISMS. Then there's a requirement for integrating controls into AI processes. So for example, the best practices which we covered earlier in the slides, whether it is data provenance, data management, the error rate analysis, which we talked about, measuring the accuracy or the recall with certain measures, measuring the explainability and transparency as well, reducing bias, all those controls need to be embedded into each AI project. We have a set of 38 different controls. And just as we do in ISMS and other ISO standards, we need to measure whether these controls are effective or not. So it's not just a matter of implementing them, but also an ongoing measurement of effectiveness and ongoing reporting of their effectiveness. That's what makes the AI management system not only measurable, but repeatable and demonstrable as well. There's a lot of emphasis on testing, evaluation, verification, validation throughout the life cycle of the AI. So not only during the design stages, but before you roll it out in the live environment, and later on also to whatever extent it is possible. Data management, data quality controls are very explicitly mentioned. So just like you have in ISMS and Annexure A with 93 controls, here in ISO 42001, you have an annexure with 38 different controls spanning the entire AI lifecycle. Some of the metrics which we have spoken about are also covered in that. If you look at the right side, there's a new process called AI impact assessment. And here, it's not just the impact to the organization, your organization, but also impact to individuals or groups of individuals and society at large. So the organization is expected to proactively envisage foreseeable misuse of the AI system and take proactive measures to mitigate these risks. Let's look at a sample AI risk, AI impact assessment in the next slides coming up. So here we are looking at impact to society. Example one could be inequities in healthcare, discrimination in healthcare due to bias leading to inappropriate recommendation. Imagine how serious it could be if the false negatives that we discussed or the false positive which we discussed in the loan application, that resulting that applied to a medical scenario could lead to misdiagnosis, and how serious impact it could have on the health and safety of the customers. Now, this impact has to be assessed, understood, analyzed by the organization, and proactive measures have to be taken throughout the AI life cycle to mitigate this impact. Another example could be loss of human oversight due to over-reliance on screening AI systems without critical evaluation. So we make inordinate use of AI systems in screening of resumes or loan applications or whatnot, and over-reliance on these systems without the capability of human in the loop or human intervention can lead to a lot of serious impacts on the people who are applying for this. Then look at some more examples. Discrimination. AI algorithm exhibits preference due to bias for a particular gender or particular race or particular economic background. False positive leading to inadvertent rejections. We talked about the loan example here, or loss of privacy. That means sensitive personal data being disclosed or being stolen or being used without the explicit consent of the data subject. So these are examples which organization can look at in their impact assessment. Remember, how is it different from risk management? Because in risk management, typically you look at impacts to your own organization. Now you're looking at impacts to the individual or the society at large. So that's an additional process in ISO 42001. And there's another supplement standard called ISO 42005 on how to carry out impact assessment for AI. By the way, it's important, AI impact assessment is provisioned by the various laws also which are coming up. Now here we are showing you the structure of the entire AI management system here. Lots of boxes, very text heavy. So what I've done is I've differentiated some of the unique processes with a different color. So if you look at the left-hand side, first column, 4.2, understanding the needs and expectations of interested parties. Though it may sound very similar, but here the focus shifts onto the various laws, regulations, and the contracts which you have with your clients. And what are the legal regulatory obligations that you have to comply with for AI particularly. If the organization is not carrying out this process as part of its AI management system, then the risk is huge. If you look at 4.4, the artificial intelligence management system, this is where all the various processes in the AI lifecycle has to be not only identified but formulated along with their dependencies, so that the organization is absolutely clear which process has got how much risk, how it has to be evaluated, what are the corresponding key performance indicators, and what are the corresponding key control indicators for each of the processes in the AI life cycle. So that's why I've highlighted it here. Let's move on to 6.1. We spoke at length about risk assessment proactively at the organization level, at the project level. We also talked about impact assessment, which is complementing the risk assessment. Then 6.2 talks about AI objectives, measuring the objectives at the process level, at the organization level, reporting in the form of some kind of a dashboard to the top management, and closely coupled. 6.2 is closely coupled with 9.3, which is management review at the right side. So various types of reviews happening, not only at the functional level, but top management level and audit also. Then you come slightly to the right, clause number 8, operations. Under that, I've highlighted some of the boxes here. Operational planning and control, having very clear criteria defined for each AI lifecycle process. The metrics which we have spoken about in the previous slides, having those metrics in place, monitoring them, reporting them, and wherever needed, taking remedial actions. Ongoing risk assessment. So risks are, as you know, are not constant. They will change with time, and the RTP or the risk treatment plan will also get updated correspondingly. On an ongoing basis, risk assessment, risk treatment, and impact assessment being done. That's the essence of clause 8. Come to the right side, 9.1, monitoring, measurement, analysis, and evaluation of all the various metrics, not only the error rates, not only the bias, but the data distribution, and having a plan how to monitor each throughout the life cycle. So very, very good level of granularity here. Followed by internal audit and management review, which you have in other standards as well. And the last column is improvement in terms of closure of gaps, and raising the threshold also. So that's a very quick overview of the entire ISO standard. Now, what is missing in this particular diagram is the 38 controls, because that's a separate session altogether. What are the controls, how to implement them, how to measure them, how to report them, how to improve them. So that gets supplemented with this 38 different controls in addition to all these mandatory processes. So let's have another poll. Is there a need for your organization to have an integrated approach for managing various categories of risks? Not only information security risks, not only privacy, but the new AI risks as well. Do you want an integrated approach, or you want to have a separate set of procedures, is the question here. So Chavinder, over to you for the poll, please.
Thank you, sir. The poll has launched. I
Okay.
request all participants to please share your responses. Okay, we can now close the poll.
All right. Okay.
Sharing results, sir.
Yeah.
So, 79% people are saying yes, absolutely to avoid silos.
Mm-hmm.
16% people are saying yes to some extent in our
Mm-hmm.
context, and
Mm-hmm.
5% people are saying not sure, would like to find out more.
All right. Very good. Thanks so much for your responses. We have a very responsive audience. I really appreciate that. So we've done this. Okay. A couple of more aspects which you want to consider before we start taking your queries. So these are some of the important considerations for implementing the AI program. Look, given the risks involved, given the impacts, if it's not aligned with your business strategy, if top management involvement is not actively there, then the risk to the entire organization exists. So, so ensuring that it gets maximum amount of visibility from the senior management is one of the major aspects. Uh, Complying with the applicable legal regulatory obligations for trustworthy AI, another imperative. And and these laws are going to come up now one by one. Fortunately, they are all based on the OECD principles, which were subscribed by various countries in 2019. And some of these OECD principles are related to uh, AI for the benefit of humankind, a risk-based approach, a measurable approach. So these principles are also part of the ISO standards while the standard was formulated. So they are embedded in these ISO standards. Then talking about integrating your management system, you might want to integrate various processes such as your risk assessment, risk treatment. Maybe you want to integrate your privacy impact assessment with your AI impact assessment. Maybe you want to have a common set of internal audits or a common set of management reviews and a consultative approach. So you need to have an inclusive approach in which you are not just consulting the various CXOs like the CIO or the uh, data protection officer, but also you have in your team ethical experts who are looking at the model performance from an ethical perspective. So that will help you enable more trustworthiness. And then what kind of governance mechanism do you need to have at various levels in the organization, and what skills do you need on an ongoing basis for the various people who are actually involved in the AI life cycles? Some of the major considerations, all of them are addressed by the standard as well. Now, this is the last poll, so we want to solicit your perspective on where are we, where are you in terms of your maturity for the AI program. So we've given some 4 options. First one says only a roadmap for AI adoption exists, no management system yet. The second one is basic management system exists in terms of policies, processes, roles, and technology, but then we want to take it further to the next level. And option C says AI solutions are integrated in our existing products, services, and tools. Independent assessment not done yet. And fourth one is saying everything done. We're absolutely the best in class. So where are we in the journey is the question. So over to you, Chavinder.
Thank you, sir. So we have launched the poll question. I request participant to please give your responses to this poll. Okay, now we are closing this poll.
Okay.
So the result is 57% people are saying they
Mm-hmm.
have only a roadmap for AI adoption.
Mm-hmm.
9% people are saying they have basic infrastructure exists. 30% people are saying they have AI solutions are integrated in their organization. And
Mm-hmm.
4% people are saying they are the leader in the AI services.
Very good. Fantastic. It's good to hear that. All right. So I think we're done with our session here. And on behalf of my team in BSI, I thank you for your time. I hope this was meaningful and worth your time. We are happy to take some questions now.
Okay,
So,
sir.
Chavinder, do you have something in the chat? Do let me know. So, put your questions in the chat. We'll do our best to answer whatever we can, and then the remaining questions we'll answer via email.
Sure, sir. So we'll take only two questions at the moment because now we already over the time.
Okay.
So, sir, the first question is, will the clauses in ISO 42001 AI
Hmm.
management standards be
Mhm.
similar to those in ISO 9001,
Mhm.
or
Mhm.
will there be significant differences due to the specific focus on AI management?
Hmm. So I think very good question. Thanks so much. Partly you have answered it. The answer is point number B, which you just mentioned. Although the principles are same as QMS, which you could see in the nomenclature of the clauses, but let me assure you, uh, this is hugely different from what you're already doing in a QMS because specific controls have to be implemented, specific key performance indicators have to be incorporated, a whole new set of policies, procedures has to be brought in. So while the principles are the same, there's a lot to be done. I hope that answers your question.
Thank you, sir. So question number two is, are there any specific industry-wide standards
Mhm,
related to
mhm,
42001, like
hmm,
for automotive, pharma, or medical device sectors?
mhm. Yeah, so this standard caters to it is sector agnostic, first of all. Uh, you may have certain best practices which are coming up in EU for automotive sector also. Those can be readily integrated with the ISO 42001. Uh, Many of the concepts are the same. So for example, we talked about what kind of metrics, what kind of uh, considerations, whether it is transparency, uh, accuracy, or bias, uh, or security, privacy, they are common. Yes, sector specific specifications may be there on top of this, but they'll be supplementary to what we've already discussed. In addition to that, so once you have a base of management system practices, you can easily upgrade to those specifications as well. There will be more specifications coming up.
Thank you, sir.
Chavinder.
And now I'll just ask the last question because we are going
Okay.
over the time.
All
So,
right.
how does security and privacy controls aid
Hmm.
with AI security, and what specific AI controls are introduced in ISO 42001?
Hmm. So there are two parts to this question. First and foremost, uh, AI management system has to be complementing the existing ISMS and privacy information controls which you have. Obviously, you will extend those controls to the AI lifecycle as well. That means the softwares and the practices and the SDLC models that you have, you will be extending those controls for AI also. But those controls will help you a lot in accelerating your AI implementation. So these 38 controls, which is the answer to your second part of your question, there are 38 different controls. So I'll give you some examples here. Those controls will be around first and foremost data management, which were not there in the other standards. You wouldn't have them because data is the vital ingredient. Data provenance, data management, data quality. There'll be some controls related to AI lifecycle, which is uh, how the design has to be done. The AI model has to be designed, how customer specifications have to be taken into account, what kind of validation and verification has to be done. These are explicit controls which you will not find in other ISMS, PIMS standards, which are part of the 38 controls of ISO 42001. Then going forward, there are all other controls related to AI lifecycle, stakeholder management, etc. So so the majority of controls will be on responsible AI, data governance, data provenance, design and development of AI model, uh, testing and evaluation, verification, validation. These are, you can say, additional controls which you may not find in other standards like ISMS, etc. To answer your question.
Thank you so
Shavinder,
much,
back
sir.
to you.
Okay, sir. Thank you. I hope now we have taken the enough time and you have answered all the question which has been asked on the initial level by the participants. So now I would like to thank each and every participant for joining us for this today webinar. And thank you so much, Dheeraj sir, for delivering such a beautiful presentation on this topic. And I hope like all our participants, they'll get a entire knowledge about the ISO 42001 in terms of the topic context. And before closing this webinar, I would like to request all participants, post this webinar, you will receive a quick survey. This quick survey will take only of your 30-second time. It is related to the feedback on this particular webinar. So I request everybody to please go to the survey and share your responses with us. So it will help us to deliver such kind of topic to you in a more improvised pattern. And thank you so much, Dheeraj sir, once again.
My pleasure.
We can
My
now
pleasure,
close this.
Shavinder. See you then. Thank you. Bye bye. Bye,
Thank
everyone.
you.